Yes, I really changed databases again. I know, I need to stop doing this. You've probably already seen the video where I talked about the other 3 database changes that I made. Well, I hope this is the last one because it has been a wild ride. We're going to be going deep on the new database I chose, which, spoiler alert, it's Convex, how I got there, what we're seeing as the benefits of it, and why this migration took 5+ years off of my life. I had the most chaotic debugging session that lasted like 4 days. I effectively thought I was solving a murder mystery at a point because I was so deep in. I wouldn't wish what I went through there on anyone. And before we go that much further, I want to clarify that almost none of it was Convex's fault. But I think there's a lot to learn here, both from the hellish nature of this debugging that I had to do and the painful 11:50 p.m. on a Friday ship we did that broke things for a ton of users, and how we finally got to a place where I am confident enough in our database setup that not only am I ready to hit the go button and ship it to all our users, but I feel like my team is finally unblocked. The goal of this whole migration was to make it so the other engineers working with me on T3 chat can make changes more confidently. Because as great as parts of my sync engine were, oh man. So if you're interested in a deep dive on everything from sync engines to chaotic authentication debugging stories to a set of patches being made on the Brave browser due to things I found in the process, you're in the right place. It's going to be quite a video. But after losing multiple nights and years of my life to this one, I'm going to say a thing I very rarely do. I'm underpaid. So let's do a quick word from today's sponsor, and then we'll get right back to it. Do you like making a bunch of money? Do you like selling to enterprises? Okay, no one likes selling to enterprises, but do you like their money? I know I do, which is why I've been struggling a lot to try and build an auth platform that will let me sell T3 chat to these businesses. At least I was spending a lot of time figuring it out until I realized WorkOS kind of just solves all of the problems that I was having. If you never had to deal with SAML, SSO, Okta, and all the chaos that these enterprises need in order to get things set up, I envy you. I genuinely do, because it's not fun. I'm a team of 3 trying to sell to Microsoft. It is not in our interest to spend all our time building these crazy PKCE platforms to do things that I can't even pronounce. It's just not what I should be spending my time doing. And if you're watching this channel, it's not what you should be spending your time on either. You need to ship. If you want to spend weeks going back and forth with an enterprise customer you just landed in order to get everything configured properly, feel free to do that. Or you can use WorkOS and send them a link. They can literally click 2 buttons and get everything set up regardless of what identity provider they're using internally. Do you know how annoying it is to do these things otherwise? I've been there. It's not fun. By the way, you can generate the link via the SDK, so you don't even need to send it by hand. And if you are one of those people that's running a smaller business that's trying to grow and you're worried about paying a bunch of money for this when you're not going to use it, you have nothing to worry about. That's 1 million users for free. Yes. Really. If you want enterprise-grade auth without all the hassle so you can sell to big companies, check out WorkOS today at soydev.link/WorkOS. So before we can go much further, we should do a quick overview of where things were before the migration. Things started relatively simply. I actually talked about this in a video I filmed a little bit earlier today. This is the setup that I previously had when we launched T3 Chat, and I miss it dearly. It was so simple and so consistent, but it had problems. The TLDR is that I had everything locally on your machine using Dexy, which is an IndexedDB wrapper from a forgotten time. You can tell from the website. Dexy was written with IE 7 and 8 support. Legendary library. It has made my life much easier, but syncing it was a challenge. So all of your data was stored in the Dexy IndexedDB instance. IndexedDB is a browser API for storing large amounts of data in a key value store. It's such a mess that I have a whole separate video planned about it. It's going to be why I gave up on local first, because IndexedDB is the browser API to make local first possible, and it is a shit show. I couldn't recommend it to my worst enemy. It is painful. I don't want to make this video about that, but I'm going to give one quick example. A given IndexedDB instance can only have one connection to it in the browser. So if you have 2 tabs on the same app, only one of the tabs can be connected to the IndexedDB, which means all the other tabs have to handle things through events and message passing between each other. It's so bad. So, I could spend a lot of time complaining about all of that, but instead we're going to talk about where things actually went. So we stored all of the data locally in your IndexedDB instance with Dexy. I had your threads and I had your messages. I would JSONify those. It was actually super JSON, so things like dates would be honored in the serialization. I would then gzip it so that it was a much smaller binary. And then I stored that in Upstash, which is a Redis KV, the key being your user ID, and the value being the gzip blob, because my database was very simple. A key value store where your entire database instance was serialized and thrown in here. So when you sent a new message, and the new message was generated by our AI and shown to you in the UI, on complete, I would update the IndexedDB instance and then trigger the update function that would rezip up everything and post the whole thing up. I did some testing where I had like hundreds of threads with tens of messages each locally. And after gzipping it, it was only like 600 kilobytes. So I was like, okay, this is going to scale pretty far. I should be fine for a bit. I did not expect users to paste like the entire documentation for 3 different libraries and their whole code base in as messages, which caused this to break for a small number of users very badly. Which is why I then broke it up to have threads and messages as their own separate keys in the Redis instance. But I had to make sure that you could only update things that were yours. So the keys became something like this. We had like message : user : 1. So that's the user ID, some UUID, which was the UUID they had generated for the message. So if they were faking it on the client and trying to override someone else's messages or threads, they couldn't, because in Redis, they were identified by the user ID as part of the key. This made things significantly easier for us for persisting. And if you were a signed out user, you just couldn't persist at all, which made things extremely easy. Until you had to query for thousands of things in Redis on page load. Then it fell apart pretty aggressively. Or if you had a thread and it needed a bunch of messages, the threads didn't keep track of the message IDs. The messages had message IDs in them. So I would have to download all of the things from Redis for you as a user and put them all in IndexedDB and then do my best to sync up the right changes at the right times. And I got it mostly working. And then I saw how insane our throughput was on Upstash and realized that I needed traditional DB for this, especially because we're doing more relation-y stuff. So I spent 2 days doing this move, and then I spent 2 hours taking this and throwing it on Planetscale using Drizzle instead, which was surprisingly easy once I broke it up into individual things. But there's an important detail on how I did that that will be the start of everything we're about to cover. This is the schema for our messages and threads when we were on Planetscale doing traditional SQL stuff. Notice anything that makes you concerned. There's one thing in particular that should raise red flags. Here. I wasn't storing a bunch of different keys that represented the data for your message or the data for your threads. There is no status, there is no content, there is no title, there is no model, none of the things that we expect, none of them are mapped here. I only mapped what I had to in order to handle the absolute fucking chaos that was taking your local synced data and putting it up on the cloud and updating the right parts. So this data field is a super JSON string, which, by the way, super JSON bloats the size of these have done. So we probably were storing 4x more data than we needed to. Fun mistake to learn from. So how was the data shaped? It was shaped in the folder that ruined my life, local DB. Here is the Dexy code that no longer exists in the main branch. Deleting this was such a career high for me. Here we have Dex thread, which is the thread that is stored in IndexedDB. So when you do things in the original T3 chat implementation, you are touching your local IndexedDB instance instead. So I update a title, it changes here in Dexy locally. When this gets persisted on the server, I take the whole value that I have in IndexedDB, I stringify it with super JSON, and then I post that up where it gets written to the DB. So the actual content is all defined here, which is particularly nice because it means we can make changes to the shape of data without having to do database migrations. It also means we can do experiments, we can have different things going on in dev, and most importantly, everything relies on local. So when you do things on the client side, the server just maintains the history of what you've done. It doesn't care about the shape of any of it. Then I had to start dealing with all the problems that come when you build your own sync engine. Like the one that's haunted me forever now is delete persistence. I've changed how we manage deletes probably 5 or 6 times at this point and never quite got it right. We always get new reports of deleted threads and messages coming back because no matter how many different ways I try to set it up, we hit some edge case that breaks. So it's annoyed me forever. That all said, since it's all local, we can do things like set an ID that's part of the URL and set it on client by just calling crypto.random UUID on the user's device. And it's fine because this all gets serialized in a JSON blob that doesn't allow you to override other users' things. Even the ID value, okay, this ID is just an increment coming from MySQL, but the user provided ID, this is the ID that the user gave for the message, and I append the user ID in front when we write it. So it's the same pattern I showed before, but man, were we hitting a lot of edge cases. The biggest edge case being IndexedDB just not fucking working in a bunch of places. I don't even want to think ever again about all the race conditions we were hitting in Safari. I am so happy to have exited IndexedDB, and I feel bad because Dexy was awesome. It's one of those rare gems you find that takes an API that's so fundamentally broken and makes it totally usable. Dexy did such a good job of making things usable for me inside of IndexedDB that it misled me into thinking IndexedDB would be a good choice. Oh, look at that. Look at my cute innocence. 4 months ago, the original commit where I did this. We are local, baby. OMG, this is so good. I miss that innocence so much. I wish I could go back to how I felt when I thought this was all going to work. Oh, man. In order to understand where we ended up, we need to talk about what I wanted. The key things I wanted. First and foremost, as we've established, I wanted off of IndexedDB's wild ride. I was out. We'll do a dedicated video about all the weird quirks and shit I dealt with in the time. Just trust me when I say it's not worth it. I also wanted to solve the split brain problem. When I say split brain, what I mean is your definitions living in multiple places. Even here, where I have the actual definition of what data we have and use living here inside of the IndexedDB Dexy stuff, I have a separate message table that is a different shape. Thankfully, this one is just a key within it, but that's still two different things that have their own consequences. This data lives in multiple places, which means there isn't really one source of truth, so to speak, especially because different clients could have different versions that are in different states. So I have to handle all the different migrations, which we did down here, where I have the upgrade that has the v3 migration. So if you were on the third version over IndexedDB, before we were storing statuses and the model you used, because when we originally shipped T3 chat, you only could use 4.0 many. So we had to add that, and I added it by migrating and setting that value automatically on things that didn't have a value set. V4, I had to do a bunch of changes. We added search. We had to generate the search tokens. All the search was local. Later on, we had to do user-edited title because we allowed you to edit the titles. That's a new field. We have to default it to false so that it's always set. We also changed how statuses worked. Then I had to update some bad decisions I made about how threads work later on and do a huge backfill for that. All of this runs on the client all of the time. And all the sync logic's in here too. I don't need to harp on this forever. You get the idea. Single source of truth was a specific goal we had in mind. This ended up ruling out a ton of the options you're probably thinking I should have looked into. We'll get to those in a bit. Don't worry. Just please don't say 0 over and over again, guys. It doesn't work for this. None of this works for that. Needed to make sure we had good optimistic updates so that when you renamed a thread, deleted a thread, sent a new message, all those things could be immediate. A huge part of why T3 chat is great is it feels incredible to use. So we had to make sure we didn't give that up in the process. I would argue that these were the essentials, but I needed more in order to justify the effort because we've already migrated so many times. So the additional benefits that I was looking for were resumable streams. So if you disconnect while a message is coming in, like if I just go to the existing T3 chat production and I send some message on a slower model, I tend to pick R1 via Open Router, not because Open Router is slow, but because R1 is slow. The distilled ones are fast, but standard R1, not fast. Write 3 poems about sync engines or databases. Now it is doing the thinking step. If I refresh, instantly is killed because that request was going to the browser from the server. My server never updates DB. The server will generate an AI response, give it to you, and then you updated the DB, which means if anything happens in that time, you lose the message. Resumable streams has been a hellish problem for a bit. And funny enough, right as we finished our changes, Vercel put out a package that kind of solves it. But that package actually is much easier for us to use now that we have migrated our own solution. We'll get to what I mean by all that in just a bit. So here we have a state users would hit a lot, where if the tab falls asleep when you're waiting on a slow generation, or the easier one, and this one I would hit a lot. We're generating this. I'm going to go accidentally open the same tab in a different browser. Oh, that put us in a broken state. It just thinks it's loading. Oh no, an error occurred when I refreshed. Here, it's still waiting for the generation to happen. It's very easy to get into these states when you build your own sync engines, especially when those sync engines rely on the client to be the source of truth for everything. So I could actually even put that in the list of things I wanted. Client no longer source of truth. I'll be honest, I do not trust you guys or the browsers you use to give me the right shape of data ever at this point. I don't like clients, and I don't like the fact that all of my users being devs means they screw with things all the time. I remember when we first set up the paid tier and we restricted what models you could use. If you set a model that you didn't have access to, we would just run it with 4 many. And I got so many DMs and Twitter dunks of people thinking, oh, I'm getting Claude for free because I changed the name of the thing in local storage. So I went and added special code to give them a custom error saying, nice try, nerd. But like those types of things are all because I have to trust the client, because the client's the one that controls the whole experience when I build it local first. I don't want that anymore. Leaving client-defined behavior to mean the client experience degrades. One more thing that is an essential for whatever we're moving to, and I found so many solutions suck at this. I'm going to put it over the line for like essentials. The other essential is that signed out experiences are good. You would be amazed how many of these solutions assume a user is signed in before anything else works. Most of them, I would say this is the case. And the final thing, I was going to put it in helpful, but I think I'm going to put it up here. Unblock my team. When you build your own sync engine, you now have to maintain your own sync engine. I know that sounds obvious because it is, but that means when you need to make changes to the data model, the sync engine has to be touched. And if your sync engine is complex, which, spoiler, all sync engines are, you now have to deal with the consequences of that. This is why things like preferences didn't sync before. This is why things like your pinned models didn't sync either. This is why a bunch of the features we want to implement are taking forever to do, because they all involve interfacing between that local store, our APIs, our chat generation endpoint, and our database for persistence. And the orchestration across all of that is kind of hellish. I accidentally created the torment nexus for poor Mark. You get the idea. It was rough. And I still feel bad for what I put the team through. So this was one of the biggest reasons I wanted to do this. I would not migrate my database if I wasn't confident that the new solution for not just where the data is stored, but for how we think about data in our app, I had to be confident that would let me not be the one doing everything with the database going forward. Because I'm too busy to be the only one who can make changes for those types of things. And I've been blocking way too much work for way too long. Problem solved, hopefully. So I was looking for a solution that covered all of this. So let's do the first one you guys are thinking. I know how this community works. Zero. I really wanted this to work for us. Zero is a very interesting project. It was built by Replicache, which was like the original database sync cache layer company, with the goal of making something way simpler to set up that integrates more deeply into your application logic, that lets you keep a really good local experience where things are synced, mutations happen locally, and then get persisted to the server. And it really did seem like the solution, but it had catches. The first one obviously is Postgres. If you've been around for a while, you know I'm not the biggest fan. They planned to eventually do MySQL, but they're not there yet. Totally fine. The bigger catches are how you actually set it up. You obviously need to have infrastructure managing that WebSocket layer that connects to your clients and triggers the updates. They had yet to do provisioned infra, so you had to spin that all up yourself and self-host. Still not immediately opposed, annoyed, but not opposed. The problems start to come when you realize the way the schema works. They have since changed this, I believe, because of me and a few others being annoying about it. The problem was that you had to redefine your schema in multiple places. You'd have to define it in SQL to actually get it defined, or using an ORM to generate migrations and whatnot. So you have it in SQL. You'd have to mirror that for your table definitions for the sync layer between the two. And you would have to mirror it on the client side, as well as the permission system for it, in order to make sure everyone has access to the right things and that you're getting the right data at every layer. So you write your schema. You can use their syntax for it now. I don't know if this will handle things like migrations for you now. There was some work on this partnering with other ORMs and whatnot. I don't know what the state of it all is. At the time, it was not ready at all. You can create your schema using their new helper. That's actually really nice. A lot better than it was. Oh, cool. Yeah, you can use their migrations now from the zero schema. That's a huge improvement. Their query syntax, now that they have this new proper z.query thing, is a lot better than it was when I first played with it. But once you need to access it on client, you have to deal with auth. Now you have to set up zero with that, and you have to manually map for all the different permissions, for all the different types of data, your custom permissions functions and your custom permissions bindings in your permissions layer that now wraps that schema. This is a complex layer that requires a lot of work to set up. When I played with the first example code base with this, it was a bit of a mess. Let's take a look at zbugs, which is their example. So in shared here, we have our auth ts file. Assert user could see comment, assert user could see issue, assert is creator or admin, assert is logged in, as well as the auth data schema. And we have the separate schema where all these things are defined, but none of the permissions are defined in here. Those are all now separate. Relations are defined with issue label relationships, which is a relationship from their thing. You're starting to see this. And then we have the permissions at the bottom here. Return type of defined permissions. Yeah, it's a lot. I am thankful that they have done a lot of work to solve the split brain, that this shared definition can be reused in multiple places. That was not the case before. That's a huge improvement. But it was a lot. And I was not confident that it would solve either the split brain problem or the unblock the team problem, because it seemed like it would be yet another giant pile of code to maintain. And the cool thing with Convex is if you delete the generated directory and just look at the code files I changed, I ended up with less code that's much more maintainable. So that wasn't a realistic solution. I looked into a lot of different state management solutions that had DB bindings, but I still had to deal with the multiple sources of truth between the client and the server. The split brain almost seemed inevitable, unless I was to move everything up. But if I moved everything to the server, now I have to deal with triggering updates on the fly. Now I have to deal with resumability for things myself. Now I have to deal with all the weird partial states. I have to deal with optimistically updating the UI. So I needed something that was really tied to my app. I needed an application DB. A thing that's been tough for me to accept for a bit now. So there's a huge difference between a database and an application database. I already knew this about things like analytics, where ClickHouse is a very different solution from Postgres, or BigQuery is very different from MySQL, where the priors are built to do massive amounts of data and read huge things that take multiple seconds, if not minutes, to respond. But it can just handle these huge piles like data warehouses. And obviously data warehouses, even if they can do SQL syntax, are not a traditional DB. And I've now accepted that applications are similar too. This has catches. It means that if you're using a DB that's well optimized for applications, it's probably not going to be good at things like analytics. If we wanted to know how often things happened in our current production environment, we could query the MySQL database and get info from that. With Convex, that's a little more complex, but it solves everything I listed here. It even had a decent signed out experience piece, which most things didn't do well. The resumable streams was a problem. I guess we have to tangent a little on this problem because it's important to understand. If I generate a message on T3 chat, I'm just going to regenerate this one. Wait, no, I can't use this in Zen. This is one of the reasons I hate using Firefox for my dev stuff, because if I go to the network tab when this message is generating, we can't see the chunks coming in as they come in. They're clearly coming in. But if I was to go do this here instead in a Chrome-based browser, here we're actually seeing the streamed response as it comes in. See how fast it's updating? It's like breaking this, but you see each token as it comes in. And if I stop that, you'll see we're getting these individual rows, which are individual parts of what it is writing, broken up into tokens, which is how AI generates things. So we have, okay, comma, the user wants 3 poems about sync engines for databases, period. These are all coming through as server sent events, individual lines in my post request response over HTTP. And I just update the UI whenever one of those comes in. My ideal world would be something like this. If we have our user, obviously users are circles, and I have my /API/chat endpoint, And this endpoint is what generates the message that the user sees. And I have the DB. What we were doing before was effectively this. User sends the request to API chat, which authenticates them, makes sure the request is valid, figures out where it needs to go, and then sends it to the LLM provider. So generate message request. The server then sends down to the user the streamed response with all those individual chunks, and then I write it to the DB. So persist. The basic flow, user sends the message request to the API streams down the result, and then the user persists it to DB. So what happens if the user dies throughout? The data doesn't make it to DB, everything falls apart. So what would the ideal be? My ideal would be this. We send the stream to the DB, and the DB sends it to the user. This adds a little bit of latency at the start, but this seems like it will solve all my problems. Except for one thing. Let's look at how these same updates come through using Convex. So we're going to go to beta.t3 chat, grab the same slow instance of R1. Cool. So now as that streams in, we're going to look at the messages we're getting. Here, we're getting these transactions, and these have a modification. The modification is a bunch of data, including the reasoning. And if we go to a different message here, you'll see modifications, type, value, the whole message still. So every time an update occurs, we're not just sending down the little bit of data that changed, we're sending the whole message. So if the message is something like this, we're just sending 1, 2, 3, 4, 5, 6, 7, 8. Instead of sending down 1, then sending down 2, then sending down 3, we send 1, then we send 1, 2, then we send 1, 2, 3, etc. What's even worse is I am watching the thread. So if we had a previous message, which was count to 10, then we send down count to 10, comma 1, count to 10, comma 1, 2, count to 10, comma 1, 2, 3. See the problem? We send ungodly amounts of data down if we update on every token. The reason it works this way is because the sync engine isn't watching for what changed on a row. It's watching for which queries had rows change. So if we update a message, and that message is part of a thread query, it sends down the updated state of that query, which is why these systems can work at all. It makes everything significantly easier. But what it's not doing is sending down a diff on a row. It's not saying this row changed in this way. It's saying, here's the new state for the query that you requested before. So what do we do about that? The obvious solution is you update less often, or you split this up in your DB, so you're sending down individual tokens instead. But then you're storing individual tokens, and we have generated billions of tokens on T3 chat. We're not doing billions of rows. That is not viable. So instead, what you could do is you can chunk it. So instead of sending one token down every time you get one, you send down a portion of it every time you hit a threshold, maybe a new line or a timer. We send down an update every half a second. That significantly reduces the throughput of how much data is going down, but it also regresses the user experience, because if we generate something, I'm going to switch to a faster model, like 2.0 Flash. Do you see how fast it comes in? Watch what happens if I regenerate and refresh immediately. Oh no, why'd that fail? Oh, that's because I'm in the non-beta version, so it will fail when I refresh. But if I go back here, regenerate, refresh. Oh, that's a fun new bug. I'll have to fix that one later. It didn't actually change the thread that I resent that with. Cool, lesson learned. But if I'm refreshing, you see it's coming through in big chunks instead now. Instead of the individual message updates, it's coming through in chunks. I right-click, re-roll this with Gemini. You'll see this very fast-moving one is now coming through as paragraphs, effectively. That's a regression. It's nice that we can get the updates at all when you lose your connection, but if this was the only way we did the update, we'd be fucked. So what we're doing now is this. We send the SSE response down to the user so that you can render it immediately. But if this gets killed, if you lose this connection somehow, because, I don't know, spotty internet, refreshes, you went to a different device, or maybe you're doing this as a shared chat experience with others, SSE response doesn't matter, because we're sending a chunked response up to the DB that updates less granularly, but still gives you the latest state, because the source of truth is always the DB. all this response is being used for is optimistically rendering the tokens when you get them. When all of this clicked, I realized that Convex could be a phenomenal solution for us because I could use it to easily update the WebSocket that keeps track of the query, to keep track of like the state of the message, the model you selected, the other threads, which threads are yours, your permissions, and all these other things could be done through Convex. And when I want the optimistic stuff or the better performance for the updates, I can just do that as a layer on top because Convex is just TypeScript. It's just written to work in React like any other library would, and it made it really easy to work with. And thanks for the proper terminology, it allows us to avoid quadratic message lengths. So what did implementing this all look like? Well, it meant I had to gut all the local storage stuff because now the DB is the source of truth. You know, the thing that our friend Uncle Bob says is evil? Now that I've done all of this, I couldn't be more certain about how wrong he is on that. DB being the source of truth makes life so much easier. All of the code is comically simpler for so many things that were really miserably tedious before. One example is how we would do title updates. When the server gets the AI message, it now has to take that thread and send it to, we use Gemini 2.0 Flashlight to generate a title based on the content of your thread so that you get a title that's relevant to the thing that you're doing. Previously, I had to build a whole pipe to send that down as a different type of data through the SSE response so that I could take it and write it to that local store like instance in IndexedDB. And then if you had one of the cases where you refreshed and the data got corrupted, that title would never be persisted on the server at all. It was obnoxious. And it was also a ton of code passing these serialized title chunks with certain event types from the server to the client, parsing those and then writing them properly and then triggering the update on the server was not fun. Now, I'll just go find the actual code that does it. I'll show the legacy code first. This file particularly would make me want to die whenever I had to touch it. This is the create message file. It was 619 lines. And that Dexy file, by the way, over not quite 1,000. It got so close to hitting 1,000 lines. It was bad. So in here, I have my data parts parser on the server sent event stream. I have these different types of data that I have defined on the back end. And I try my best to make a shared event like definition layer that would be used on server and client to keep things relatively type safe. It didn't go very well. I got close, but never quite got where I wanted it to be. But here we have case thread metadata. I parse it from the content from this chunk. I log it, so if something goes wrong, I have it in the console logs. And then I would await the DXDB threads update in order to write it to Dexy, so you would see the title in the UI. But I also had to deal with all of the event management on the server side for this too, and it's part of this chaotic on data part parsing thing. It was also way worse before I found the internal function in the Vercel AI SDK that I could use on the client to parse the data like using their responses. I hand wrote my parser originally, and it went surprisingly well considering the fact that I fucking hand wrote it. But I had one or two edge cases 2 months in that were annoying enough that I moved to their parsing, and it's been mostly fine since. Funny enough, the bugs I was trying to fix by using their parsing weren't fixed because there have been so many times where I had a bad decision I made, had a bug, fixed the bad decision and did things right, and then it didn't fix the bugs. The bug was some other layer. That happened a lot throughout this. We'll have a couple stories about that with auth in particular going forward. So this isn't even showing the server-side code. Let's find the thread metadata send on the server side. So in process request, I have my thread metadata promise. It matches generated title, so it's not an error case. Data stream, write data, write it. Then I have the thread metadata promise, results async, validate, make sure that we are generating things that we should. Generate title from user message, where I actually send the message content and the unique identifier to trigger the generation of the title. And then send this down using an async result from, what's it called, never throw. Promise.resolve, the validated input, thread metadata on the else case. Otherwise, we're just returning the result of this promise. And then that has to be thrown into the data layer. Okay, thread metadata here. I'm writing this to the data stream later on in this chaotic process request function, which is also 300-line single function. Not fun. So what does this look like now? My new create message file, less than half the size, significantly easier to work with, mostly passing things back and forth for the message generation. But the part we care about, create message, I get the current messages, which are almost always going to hit the cache, so this takes milliseconds, not even. I generate the new user message. generate the new assistant messages where the result's going to be streamed in. Convex client mutation, this is when I generate those messages in Convex, so the database has somewhere to be written to when the server starts. And then I finally call the do chat fetch request. This is the function that actually calls the /API/chat endpoint and does the generation. Fetch, method post, body, JSON stringify. On error, I will write to Convex because there are some error cases that I can't write on the server. Like if I get an auth error, I can't write that to DB because if you got an auth error, where do I write it? Because I don't know you have permission to write to that message anyways. So here, I use the set error message function I wrote, message ID, error message, error type, and auth info. It makes sure you are you, and if you are and you have permission for that message ID, I update it. This is the only place here where I, on the client side, am updating the message state during a message generation because certain errors I can't update on the server side. Most of them I do, though. Then we go down here, await process data stream. This is the optimistic updating. I have a temp store where I send the chunked stuff, but if I just delete all of this, it will still be able to get the updates from the chunked stream. This is all just optimistic stuff. I could literally delete everything here and it's fine. But where is the title change? None of this is updating the title. How does that happen? Process request has my new caller with title gen promise. This is all the same as it was before, but there's a dot then with the title. Server convex client dot mutation. API internal chat update title for thread. And I pass it the new title. The client automatically gets the update. This felt magical once I wrote this code. I got to delete so much glue, all these data stream manglings and parsing and unparsings between server and client got deleted in favor of calling this one thing that just updates it in the one place it lives, which is the Convex database. Being able to do this for a whole bunch of different things was such a game changer for us. We just look through the file. Update message content takes in content, reasoning, status. And I trigger a call where I update that via the mutation. Now I can chunk, and then every 500 milliseconds, I trigger an update with the new text data. And when it's done, I wait until the update that it's done. And if I get new metadata from the provider, so like things like search grounding or image gen, stuff like that, instead of having to handle all of those cases and all of the data being serialized and passed down in formats I don't know or understand, I just take it and I write it as an update to the message on the server. No more weird chaos getting data from server to client to DB. No more mangling or parsing. I take the thing where it lives, which is the server, and I write it where it should stay, which is the database. The only reasons this can work are the sync engine that Convex provides through their WebSocket layer on top of their transaction layer. But more importantly, because my queries aren't SQL. If this was all just done through SQL, guaranteeing permissions, tracking changes, knowing what changed when and who cares would be nearly impossible. But this chat update message API is also TypeScript. It takes in arguments, has a handler, it grabs the message from DB. There isn't a message, I throw an error. There is a message and it's done. I don't update messages that are already done. I then define the update and I patch the message with the update. That's it. That's actually it. Since this is TypeScript, it's able to operate like an API. I can check that the message is from the right user. I'm effectively doing that here with the index, where I'm only selecting the message if the message ID and the user ID match. So if they don't, I can't update it. Awesome. And there's so many of these little things that have added up to an awesome experience. But the real magic of Convex is that once this fires, any query that is querying for data that this touched then gets sent an update. So we have, if I go to like use thread data, this is the hook that renders the threads in the sidebar. Use session query api.threads.get, up over here. I grab the top 200 threads. I separately grab the pin thread so I can combine them together. The thing that's magical here is that this query, after running, gets flattened into a single transaction. And now that transaction can track what data it touched. So if that data changes, it knows anyone listening to this query needs the update. It's so nice. I didn't have to write any special code to change the state of the UI or to keep things synced on DB. I just updated DB and the user had the right state. It simplifies so much stuff. and it has made maintaining this code base significantly less painful. Getting here, though, I felt a lot of pain. I basically had to rewrite all of the scariest logic in the code base while the team was still doing iteration and shipping features. The merge conflicts I suffered through are the only reason I don't feel bad about the merge conflicts I made everyone else suffer through. I literally had to spend like 4 hours on a merge conflict that had conflicts in 30-something files. It was hell. But it was all worth it because this setup is significantly easier to work in. But that meant things like certain flows that we had in the product became very different. Like the idea of a fork button. The way this worked before is I would use your local DB. I would copy all the data in your current thread. I'd make a new thread with the branch parent ID, and I would make new messages that were exact clones of the original messages. This was all local. I could do a bunch of queries back and forth, and it was fine and dandy. Now, the fork button has to behave a little differently because all that has to happen on the server. So it's one of the few things I'm not doing optimistic updates for right now, which sucks, especially if you're on a slow internet connection or an internet connection that's far away from our Convex instance. Branching doesn't happen instantaneously when you click the button now because it has to wait for the server to look up all the things that are needed for the branch, create the branch, and then redirect you to it. So if I click now, it took time. Whereas on the original deployment, those types of things could be literally immediate. I'm clicking now. Effectively happens instantaneously. That sucks. And I will be able to do that optimistically. It's just a lot of somewhat painful code to write. So we'll get there when we get there. But those flows were different enough that it required a lot of work to fix. And all the different places we have things like branching or regen, all the fun features we have around it. Like at the same time, Dom was working on this awesome retry with different model flow. So to make sure that would work with the new way of generating messages and the new way of updating threads, I had to touch every single bit of glue in the entire code base to make this change. So to all of the shit posters saying, how did you screw up a database migration that bad? You should be able to do it in flight and just write the data to both places and everything should be fine and dandy. This was more of an application rewrite than a DB migration. I called it a DB migration because that's the interesting part and that's like why we were doing the rewrite, but it was effectively a rewrite of all of our most important client-side code. I have been recording a lot less content lately because I have been no-lifing this, pulling like 10-hour days coding on this for a while. I have the PR open here. And when I was scrolling, just trying to get like the history so I could share it with you guys, I hit a very funny thing I hadn't seen in a while. 110 hidden items. This PR had like 140 plus commits. I did like 6 branches off this feature branch. It was 5,200 lines added and 3,300 removed. A lot of that was the cursor rules I added, the generated code from Convex, which you should commit. It makes life a lot easier. And a couple legacy things I couldn't delete yet because I was using them for migrations. But like other than the 1,000-ish lines of generated code plus cursor rules, this was all hand fucking written. I spent a lot of time going through every piece of this app, fighting everything from how attachments were persisted to how messages were branched to how threads were linked to each other. I've never been so familiar with this code base, and I built it originally. But we pulled it off. I was so pumped. We handle all the weird parts from signed out states to a very much rethought schema. Because again, I now have a schema that is just this one defined schema with a bunch of tables. I had to handle IDs in a weird way because Convex has their own ID system. But if I'm using IDs to do things like optimistic updates and link between stuff, or more importantly, I'm backfilling old ones, I need your thread IDs. So thread IDs are user defined because I need to be able to do things optimistically on the client. So this ID can't be treated as unique and as like a proper identifier. I have to combine it with user ID before I can rely on it for anything. And now messages have a thread ID. This is using not the actual thread._ID. This is using the user set thread ID because that's how everything linked previously, and I needed this to work for the migration. There's a lot of these things that were rough. But we figured it all out. We have this one schema that is the real source of truth for everything. My Dexy file is gone. I still have my local DB folder because I didn't feel like moving create message and dealing with the type errors, but also some wonderfully named files here. This one for the users that had sync off. This will let me rip things from the IndexedDB instance, hopefully. But since I don't have Dexy anymore, I had to roll this all myself, so it sucks. And then I have my legacy types, which is all the type definitions of what Dexy previously was providing so that I can use these to migrate data over. Not fun. Once all that was settled, we had a schema that worked. We had sessions, which were locally stored identifiers for a user session that I could use in a logged out state, as well as a claim system for when you sign in to pull those over to your user instance. All the edge cases, all the weirdness, all the glue was done. Way less glue overall, but a lot of glue still, especially to glue the old state to the new model in order to get your things over. God, the fucking migration router stuff, this was fun. I have to have a migration solution so when you switch over, it can pull all of the old threads from DB, all the old messages, all the old attachments, get those all in the new DB. And most importantly, I have to migrate your cookies because I need your JWT for your access token to be accessible via JS, because otherwise I can't realistically get it for the WebSocket handshake. Because the WebSocket's necessarily on a different URL because it's hosted through a WebSocket service, not through my HTML generation endpoints. As such, I can't just use the cookie. And even if I could, there is not really an authorization protocol built into WebSockets, and I would have to handle that in the prefetch layer before promoting to a WebSocket. It would be a fucking mess. No one uses HTTP-only cookies for WebSockets. If they say they are, they're lying, or they're very easy to DDoS. I would encourage exploring which it is. So I have to make the cookies HTTP-only false, which led to discovering a lot of fun bugs in Brave. We'll get to all those in just a bit. But after all that is done, and we have your cookies updated so that your cookies are now set to be HTTP-only false for access token, we're mostly good to go. So I then grab all of your data from Planetscale, which is where we were storing it before. I still love Planetscale. None of this migration is because Planetscale bad. It's because I need a WebSocket sync engine. Attachment chunks, thread chunks, message chunks is get chunked Planetscale data for Convex. This grabs all of the data from Planetscale. And since I need to be sure that I'm not going over the data write limits in a given invocation of a mutation on Convex, I have to chunk it up so I'm not sending too much at once. Threads have limited title lengths and very little UGC, so the size of the chunks for threads is relatively large. I have 500 threads per chunk. Messages can be a lot longer, so I had to chunk those to be a smaller amount per chunk at around 100. I found this was a good balance where it usually would work for most people. Did attachment separately there. I now have this object of arrays that I can then, for each set, server convex client.mutation, migrate. I send all the chunks shaped a little differently so the endpoint can handle it properly. I do the same for messages. I do the same for threads. That writes all of your old data over, and at the end, I wrap up by calling the server convex client mutation for the wrap up, which does a couple attachments for some weird relation stuff that's annoying. More importantly, it has migrated to true, so you can finally go use the app. Because the way this works, and I'll show you this in like my favorite way to do it. This is my beta T3 chat running on Convex right now. I'm gonna go to my Convex dashboard. I'm gonna hide my screen for a sec. This is the Convex dashboard. It's actually very cool. The part we care about is data. I'm going to hide it for a sec so you guys don't see things you probably shouldn't. Here is a bunch of users who have migrated. You can't see it, but it says 2,806. That means we've had 2,806 people switch to the beta and to do the migration. So if I filter for user ID and I put in my user ID, we now has migrated true for me. Watch what happens when I delete this row. Did you see that? Instantaneously ran. That's the magic of Convex. Your DB and your experience for your users are always in sync. It's magical. The migration ran because I have the Convex helper. This grabs the user config from Convex. Ignore this. This was me debugging things. I get to clean up so much of this code later. I'm really excited to do that. But I gaslit myself into thinking their cache was broken, but it was actually a very obscure thing we'll get to. User config gets an update. Use effect is triggered. If I have user data, that means you're signed in. If you haven't migrated, then I know that you should. And if you're not currently migrating, then you probably should. I have this because people were getting stuck in migration loops. But I just run it by calling do migration for user, which is a TRPC call. I also will get legacy DEXI data locally if you have sync off. I then call TRPC client migration assistant mutate, triggers the migration. And then I'm done. It just works. And then the OK button, my most clever piece of code. When you click the OK, window location, reload. So it just refreshes to guarantee all the auth and everything is good. The problem was if it didn't see the migration status properly, you would get stuck in an infinite loop where this would come up every time you open the page and you couldn't do anything. Okay, I want to show off one more thing that I find really fun. Let's go to this thread, fun facts about seals. Let me hide things for a sec. Here is my seals thread. And here we have all this info about it. I'm editing data protection environment. Thank you for warning me. I'm going to change this to really fun facts about seals. That is so cool. It hasn't gotten old. The fact that I can just change something in DB from server, from client, from in the Convex dashboard, and the UI will always be in sync, it's magical. So where were the problems? I shipped at 11:39 p.m., hitting my Friday deadline. Was very excited. Almost immediately started getting a bunch of replies that people were infinite looping. This is what would happen for users. They would just see migration complete over and over again. This set me into a panic. I tried to go solve it as quick as I could, handled 2 edge cases I thought could be causing it. Neither fixed it. So I panicked, reverted, and dropped this banger. So this is a mistake. People thought the mistake here is that I shipped on a Friday. That was the only good decision I had made here. Okay, I made a couple others, but the shipping on a Friday night was really good because that's actually our lowest traffic point, generally speaking, in a given week. So the number of users affected was way lower than it could have been otherwise. Significantly lower than it could have been otherwise. But it was enough for me to know there was a problem, so I reverted. Everybody was really happy with the revert, surprisingly enough. And I put a ton of effort trying to reverse engineer what had happened. My conclusion was related to a specific bit of code. I'm going to check out the Convexify branch so we can see exactly how this was at that point. This was in Convex onboarding. Cool. So user info is the user info query. This is what returns when you're signed in with like your profile picture, email, ID, etc. So this is how I know you're signed in. User config is the thing I get from Convex as to whether or not you've migrated. And in the future, this will be like preferences and whatnot. But for now, it's just, have you migrated or not? And I have this simple check. Await context.db query user config with index first has migrated false as the fallback. So if we don't get a value from DB, I say has migrated false. What are the reasons this would come back as false when we don't want it to? Because I checked for some users and I had in DB for that user ID that they had migrated. So if I looked up a given user's user ID in our DB, it said has migrated true, but they were still seeing this because they were somehow hitting this case where has migrated was set to false, not set to undefined, it was set to false. And the user info data was set. So the user was signed in, but they were getting back has migrated false, even though the DB had them marked as has migrated true. My first conclusion is that auth must not be working properly for Convex. Remember before when I said I had to set the cookie to HTTP only false in order for Convex to have access to it? I assumed something was going wrong there. So I hit up the users that had problems and I had them show me the tab in Chrome that shows your cookies and how long until they expire, what permissions are set, stuff like that. Most of them had the HTTP only thing set proper. A couple didn't, so I looked for edge cases causing that. I assumed that was the problem. It wasn't. I saw the expiry thing and I learned that some of the places where I set the cookies, I set a max age, but I did not set expires at. And in a certain browser that begins in B and ends in rave, setting an HTTP only cookie with no expires at, even with a max age set, it will set the expires at to session. I don't know why, but it was very frustrating. So I fixed that. But at this point, I'm nervous enough about deploying this that I go out of my way to add feature flags into a whole nice fancy process for switching over to the beta, which is what you'll get now if you want to try it out. If you go to T3 chat, you go to settings, you'll see this little thing at the bottom where you can opt in to the beta. You click it, and all this does is renders a modal with a continue to beta button that when clicked will redirect you to an endpoint that will sign your current cookies as a encrypted bundle with an expires on it. Set that as a query param to beta.t3 chat. And once you go over there, it grabs that off the endpoint, sets that as your new cookies, and then loads the page properly, which actually worked really nice. It's a surprisingly smooth migration flow. It was not fun working between two versions of the same code base and trying to pass things back and forth. There's a reason I now have T3 chat and second-T3 chat on my computer. because I had to be working in 2 instances of the same code base. I wouldn't wish this on most people, but it was an interesting juggling job. So I did all of this. I had people out on the beta, and all the problems with HTTP only were certainly gone at this point. The expiries seemed to be gone too. I had flamed Brave enough that they were starting to solve problems, in particular WebSocket disconnection, reconnection problems that have been bugs for 6 years, finally getting fixed because of my shitposting. I am so proud. The best GIF I ever gave to Elixir wasn't speaking at their conference or helping out Jose Valim. The best gift I gave is that I raised the alarm bells on the WebSocket connection problems, and Chris McCord has been trying to do it for 6 years now for LiveView, because Brave users have had so many problems with LiveView, and now they're finally fixed. We have Keith in chat here, one of the best T3 chat fanboys, and also one of the biggest Brave fanboys, who is apparently chatting with Brendan Eich, the guy who made JavaScript, in this case, more importantly, also made Brave. They got the change out that finally handles WebSocket closes properly. It got merged. I don't know if they've deployed it yet or not, but it finally happened. Years in the making. The issue that is now closed has been open since 2021. It's been a problem for even longer. It had almost 100 comments over time, including a ton from Chris McCord. Getting more reports of this affecting Phoenix users. 2021. And the only reason this got fixed is me shitposting. And as stupid as my shitposting is, I'm not going to sit here and defend it and pretend my Twitter is some net good or whatever. It's pretty cool I can shitpost a 5-year-old bug into being fixed. And I would like to take a moment to be proud of that. So I'm going to take it. I earned it after all of this chaos. Let me have it. The number one Brave fanboy said it's actually very good. Thank you for that. So I'm taking my W. I will enjoy it. So what actually went wrong, though? Because none of that fixed the main problem. I will remind you once again what the problem was. The problem was that the user config was returning has migrated false, even though the correct thing was written in the DB. I'll give you more hints, because this is not an easy one to figure out. We go back to the migration assistant code, the code that runs on my backend that actually does this migration. The part that matters is at the bottom here, the wrap up migration, where we pass the user ID, the API key, just so I know you're not hitting this from the front end. Wrap up migration. Here we have, takes in the user ID. We look up the user config to see if it already exists. If it doesn't, we insert it. If it does, then we patch it. Then I do all that linking. None of this matters, I'll tell you that much. This all seemed innocent and fine. I'm passing the user ID over. I checked DB and the correct user ID is being persisted. I ruled out auth not being passed properly to Convex, which was my biggest assumption, because it seemed like there was no way this could return has migrated false if it was in the auth state and a migration had happened. So what was left? The query cache. Most queries in Convex don't actually need to read from the MySQL DB that is persisting everything. Because if it tracks every change to a given query into a given row, you don't have to care about hitting the DB, because you know if that data changed. You can just throw it in a cache and serve that whenever. Now, most requests use 0DB at all. They just hit that blind KV cache and you're good to go. I assumed, for some reason, due to either like weird nullish coalescence or the auth info not busting the cache properly, that I was hitting this has migrated false cache instance. I was convinced this had to be the problem, because I was looking in DB, and for the user's user ID, the data was set proper. They were clearly auth because they were getting data in certain places, but they couldn't get the modal to go away because this was always coming back as false. Clearly, this has to be the cache, right? I started flaming Convex for this because it seemed so obvious that was the case, until I dug into the logs very deeply. Okay, I had to add a whole bunch of logs, and then I dug into them. I could even show the updated logs. Git check out main. I had to add all of these logs because I wanted to know what was going on. I also added to Convex onboarding a force no cache with random string key, where I would just add this random UUID on every request so that I knew I was never hitting a cache for that particular check. Just seemed like all the logical things. Despite all of that, one particular user, I do want to shout them out directly because they saved my fucking ass. I'm like 80% sure I just squashed the last major bug. This was when I did the random. When I added that random no cache string, that was me saying 80% sure. I was wrong, but I was able to fix as a result of this. because Leo here, God bless him, spent a lot of time going back and forth with me, trying all my custom builds, didn't make the mistake almost everyone else made, which is when I hit them up and said, hey, can we debug this? They would say, yeah, 1 second, clearing my cookies to see if that fixes it. And that would fix it, which meant I didn't have any ability to debug with them anymore. I had 4 separate times that I hit up a user and said, please don't do anything, leave it in the broken state so we can debug it. Every single fucking time they would reload their cookies or switch browser, do something, and it could no longer repro the state. Leo was the one who did it and spent over an hour back and forth with me, sending me logs, sending me cookies, sending me everything I requested to figure out what was going on. And we figured out what it was. I'm going to show you one more piece of code because I did not see a single person come close to what the problem was. I'm not using the query helper directly from Convex when I define queries. I have my own auth query because we are using OpenAuth from the SST folks like Dax and crew because I wanted a simple, minimal JWT solution that I could fully own and control. Very happy with it overall. That all said, I had to build some custom bindings to get it working properly with Convex. Convex team made some really nice changes in order for me to have this all working. When I logged the session that I got back from Convex, when I got user through their auth helper, it had a bunch of different fields on it. One of which was like the main identifier. It had auth.t3.chat, vertical bar, the actual user ID. So my original solution here to get the user ID off it is I yoinked it off it. I just took that ID, I stripped out the auth T3 chat part at the front and just used that. I got the very innocent comment, very correct seeming innocent comment, hey, you should use subject because it's the proper clean ID. So if we go back to the Convexify branch, this get user function would grab it from context auth, get user identity. This gets the decrypted JWT that we have from OpenAuth. If auth info, user ID is auth info.subject, return ID, user ID, type auth. If no session ID, I throw an error because you always need to have a session. Otherwise, I have no idea how to do anything with you. And I will give you in a non-ID with the session ID if you were in a non-user. This was a simple entry point to make sure everything someone does is identified. So where's the problem? I'll give you one more hint. Nothing in this code is wrong. So what was the problem? The problem was that at some point in time, the OpenAuth library, if it didn't have enough confidence in the user ID it had, it would set the auth info subject, which is the identifier that it would use, to a custom user identifier that would be something like user : whatever. I found this when I was reading through the logs in Convex for the user that was still in the bad state when they were hitting that pile of logs I showed earlier. Because I saw a user ID here that was not a format I'd ever seen before. Because up until then, our user IDs looked like this: Google : long number. It's always a number and it starts with Google. But for some reason, there was something like this: user : I was immediately, I wasn't even immediately sus because it took me a minute to even notice. I actually showed the logs to Mark, my CTO, because I was curious if he could even see the thing that was wrong. I had just been staring for so long, I figured it all out. He couldn't. No one else could see it because nobody else was deep enough in our ID system to recognize that user : is not something we've ever used. It was always Google : Turns out we had some users who had signed in the first 2 weeks of T3 chat, never re-authed since. A version bump of OpenAuth that we did fixed this case. So for every single one of our dev environments and every single person who used T3 chat starting February onwards, this problem couldn't exist. For a very small, very specific set of users, session was incorrect. So I had to grab this other value, properties.id, that was nested in the JWT that was guaranteed to always be correct. But that's just a random value I'm grabbing from a key. So I have to manually cast it as a string. Now I have a user ID that will always be correct. What a fucking debugging session. This might seem unnecessarily deep. This is surface level. You guys have no idea the hell I went through over every step. I was reading Brave source code. Yeah. This was a breaking change from OpenAuth that none of us had known about that cost me 5 years of my life. When I tell you guys to not roll your own auth, I hope you fucking listen. I really do. I would have gladly paid $8,000 a month for our auth since we launched to not have had to go through all this. I am so excited to migrate to an auth provider and never deal with any of this again. You have no idea. And again, none of this is Convex's fault. I'm not even going to blame Dax in the OpenAuth, guys. It was an innocent mistake that everyone just assumed would have been resolved by now, hitting a really rare edge case I could not have fathomed. But we figured it out. The last edge case was handled. There's a couple weird things with migrating huge amounts of data that we're trying to fix for people who have like thousands upon thousands of messages, but everything's going pretty well. The one issue we have with Convex is because we have these giant messages from people's histories, and when we search indexed on the messages table, and then we're adding 50,000 rows a second consistently, their indexing collapsed for search, not their traditional like indexing for looking things up by IDs and whatnot. Their search indexing for like tokenized search, for full text search, couldn't handle the speed at which we were partial migrating. Because again, the migration is user-driven. We don't just blind migrate everything from Planetscale over. I much prefer user-driven migrations because it lets us catch things as they go wrong throughout. The only issue we had there is that their search indexing wasn't used to 50,000 row chunks being added constantly with gigantic messages to index, and I'm pretty sure they already fixed it. They promised me they would very quickly. They were learning a bunch from it. The solution is we just remove the index temporarily because they know I can add it later once the migration is done and it'll be fine. Just the only edge case we hit there. Everything else has been relatively smooth. They made a bunch of changes to the Convex helpers library, which has been critical for us. That library has been super helpful. The idea of sessions and whatnot's all encoded there. It's been great. I'm actually really happy with Convex, which is kind of crazy to say because I was so skeptical of this product for like 5 years. I remember when it first got pitched to me in 2021, and now I don't have to worry about so many other problems I had. I feel like I have a best-in-class sync engine and database team doing all the things I had to do for my team before, better than I could have done them myself. A Slack channel of people who can answer questions all hours really well, giving us huge insights throughout, helping me unwire my old brain that thought these things had to be done very specific ways, to seeing how much simpler our architecture could be. And it is so much simpler. I am so much happier with the way things are set up. It's going to be cheaper than our current DB setup. It's going to make the experience more reliable for our users. And after a couple optimistic update changes and local storage caches, it feels just as fast for the most part. I am very happy with my move, as hellish as this has been to do. And if we go back to where we started, my list up top here, we are fully off of IndexedDB now. Everything is stored in memory. Your threads are stored in local storage, just your most recent 200, so I can load the sidebar immediately still. Split brain is gone because we just have that one schema file that defines everything now. Optimistic updates aren't as great as I would like them to be, but they are so much better than React Query. I have a whole video about TanStackDB that's probably out by now. You should check out if you want a deeper dive on the optimistic update layer stuff. The signed out experience is really good too, thanks largely in part to the concept of sessions that they already had in Convex in the Convex helper library. My team is unblocked. I had Mark reviewing code through, and I was like, holy shit, this is so much better. I have a resumable stream solution. I'll go on one last quick tangent with that in just a sec. And my client is no longer the source of truth, the most important thing. My one last quick tangent on resumable streams. Vercel just published this package, Resumable Stream. It's a library for wrapping a stream of strings like an SSE web response or AI generation, very useful for us, so that you can attach it to a Redis instance. And now you have a resumable stream with an identifier, and you can reconnect to an endpoint that will start streaming whatever you have identified that way, as long as you have the identifier to link back to it. This is great, except for the fact that I have no way to reliably get that identifier on many different clients. At least I didn't. But what I can do now, and I'm actually planning on doing this, probably not after streams, I have some shit to do, but later this week, I am very, very excited to go in here, hop over to messages, and add one last field, Zoomable Stream ID, which is an optional string, so that I don't need to update every 500 milliseconds anymore. I don't have to do all the crazy throughput I'm currently doing. Instead, the stream will come through Redis where it should be, and Convex just tells me where to go. It's funny how in the end, the solution I was about to build, which is resumable streams via writing to Redis with a restoration layer that I would build myself, possibly even spinning up durable objects and a bunch of chaos there. I had mapped out the whole thing in my head, decided we had bigger fish to fry, went the Convex route instead. And now that the Convex route is done, it all clicked in my head. and I could literally, in 10 lines of code, have tokenized resumable streams once again with everything handled. Oh man, what a journey this has been. If I was to start from scratch, I would have started from scratch on Convex. My lesson has been learned. My brain has been rewired. I am significantly happier. And I am so, so happy to be done with IndexedDB. If you like the long-winded ramble that you just experienced, you're probably going to love the longer one about why I gave up on local first development. That's coming soon. Going to go much more in detail on all of the parts that made me exit over here in the first place. But I wanted to focus today on the thing that I did and why I did it, not the pain I felt to do it in the first place. Thank you for listening. Give Convex a shot. They did not pay me a cent for any of this. In fact, they're probably going to cost me a whole bunch of money going forward. But I am very happy I made the move, and I am begging them to let me write a check to invest because I've seen the light. This is so much easier to deal with, and I'm very happy. Don't migrate your database 4 times. And if you do it on Fridays. That part wasn't a big deal. Let me know what you think. And until next time, be very careful with your data.